Hello, welcome to another episode. This is episode 115. We're going to start something completely different today. The complexities of troubleshooting can often be a challenge. And to meet that challenge, we've got to have the correct equipment. We're going to start with the multimeter. Okay, let's jump right in. We're going to start with how the leads plug in. That's very important. We will jump on that right now. You've got a black lead and a red lead. The black lead always goes to common. It's no exceptions to that. The red one, however, if you are measuring volts AC, volts DC, millivolts, ohms, or semiconductor mode, it always goes here under the volt ohm semiconductor plug for the red. Alright, if you are going to measure milliamps or amps or microamps, for the amps mode, the red lead goes here. And don't forget, that lead leads you to the situation where you've got to put the leads in series with the load. Otherwise, you got nothing. It won't work if you're not in series. Alright, if you're going to milliamps or microamps, you move to this plug. And it says milliamps and microamps right there. You can't miss it. But most of the time, you're going to be right here in the volt ohm semiconductor position, because that's where most of your troubleshooting is done. Okay, the first mode on here is AC, volts AC. So if we flip to there, you'll see right there that it has a little squiggly line above the V. That squiggly line means AC. Okay, when you go to AC volts, you will see AC displayed right here. And you will see millivolts displayed just below that. If we back up just a tiny bit, you can probably see this range button. Suppose I don't want to read in the millivolt range. So I push the button and it changes from millivolts to volts. So it goes from reading 1,000th of a volt to measuring 1 volt. I've got mine set up for 3 decimal places. So even in volt, I can read that millivolt signal. It would be, if it was millivolts, it would be, well, in this case we're reading 9 millivolts at the moment, but that is just because of stray currents in the air, which 9 millivolts is tiny, and the meter may be slightly out of calibration. I haven't had it calibrated in about a year, so it could be that. Okay, we covered AC. Let's go to DC, the next one up. This is the DC. It's a V with a line above it and a dash line below that. And right now it's in the DC volt mode, and you can see right here it says DC and volts just below it. One thing that I should explain at this point, if you look across the bottom, there's an analog meter there. This little device right here, as the voltage changes, it goes up or down. Let's see if we can do something and show you. Okay, let's measure a battery. This should be 1.5 volts if it's fully charged, and it is 1.558 volts, so that is a good battery. But if you look at the bottom, you will see that meter bar moved across. If I remove it, it goes back down. So that is the analog at the bottom, and it is clearly marked as to what the voltages are. So that's how the DC works. The next range is millivolts DC. That means it reads only in thousandths of a volt. And as you can see, the scale has changed here. The decimal is now down here, so you only have 1 decimal point. So you can read up to 999.9 millivolts, which is almost 1 volt. Alright, that's millivolts. Let's move up to ohms now. Ohms measures resistance. OL means that there is no connection between the leads. If I touch the leads together, We go to an extremely low reading. The 0.3 ohms is coming from the leads. The leads have resistance in them. And as you can clearly see, it is designated ohms right here. And again, you have the bar across the bottom, which is the analog. So if I release that, you will see the bar across the bottom went all the way up. So now there is unlimited resistance between the two probes. And you look right here, it says meg ohms, which is millions of ohms. And that scale will also change. See, now we're in just plain ohms now because I have the leads pretty much shorted out. So it went from meg ohms to ohms. There is a K ohm scale in here as well, which means thousands of ohms. Okay, now, if you push this button, which indicates sound, now when you touch the leads together, as you can hear, you get a tone. That way you do not have to be looking at your meter when you're looking for a short. And a short is anything that is a direct connection between the two leads. All right, let's go to the semiconductor mode. Now, we use this pretty much strictly for diodes and any semiconductor type reading. As you can see, it's volts DC. And right there I read 0. I touch the leads together, which means there is 0 volts DC there. I touch the battery again, and as you see, it's 1.559 volts. But that is used to read semiconductors, things like diodes, transistors, IC chips, those kinds of things. Now we're going to go to the milliamp scale. On that scale, we move the leads from the ohm semiconductor to, if you want to read amps, you plug it in here. As you can clearly see, it says A right here. If you want to read milliamps, it goes here. And there is a complete, and it's AC and DC. If you look, there's a wavy line and a straight line. Now, if we go here, that is microamps, which is millionths of an amp. Okay, there are a few buttons on here. Let's start with the yellow one. It turns on the backlight. So if you're in a dark situation, you turn that on so you can see the back. The blue here is a second function, and you'll see a second function here, and a second function here and here. So if we're in the ohms mode and we push the blue button, it takes us to the microfarad reading, which is how you measure a capacitor. So you measure capacitor by hitting the blue button, and then that will tell you the microfarads of that particular capacitor. If I push it again, as you can see, it goes back to ohms. All right, if I go to the milliamps and microamps, right now it's milliamps. If I push the blue button, as you can see, it goes to AC. If I push the button again, it goes to DC. So if you switch back and forth between AC and DC by pushing the blue button. So that is a second function button. Min max, M-I-N-M-A-X, while you're taking the measurement, it will record the minimum and the maximum reading and store them so you can go back and look at those later. We've already talked about this one. This is the audio button. It creates an audible sound when you have a short. Range, we kind of covered that. Range is, it moves the range of the meter to different ranges. Real delta is the triangle is called a delta, but relative delta is the difference between the low point and the high point. It will store that for you. Hold will take a reading. If say I'm reading this, let's go to ohms. Let's say I'm reading that. If I hit hold, as you can see, it saves that when I take the leader loose. It saves whatever reading is on your meter at that time. It holds the high reading when you push that. Hertz, if you are in the AC mode and you hit Hertz, right there you will see HZ. Hertz measures the frequency, and there's a 60 cycle light above in this room, and it's picking that up through the air. It's picking up the 60 cycles through the air. That's how sensitive this meter is. It's really, really good. That's the Hertz button. So that covers all the buttons. So that pretty much covers all the functions of the meter.